What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to use some data analytics and data science concepts in order to identify the best performing EMA, which stands for Exponential Moving Average, on a lot of different cryptocurrency coins and then suggest a few trades we can take. In order to do this now, we are going to follow this strategy we have down here. First, we are going to use regression analysis in order to identify Bitcoin's trend, whether it's positive or negative. Then we are going to identify Bitcoin's best performing EMA by using a few calculations I'm going to show you later on. Then we are going to identify the best performing coin in relation to Bitcoin. So we are going to use correlation and sensitivity analysis in order to do this. Then we are going to take that best performing EMA and apply it on the best performing coin. And then we are going to suggest a few trades on that coin. Now, on this video, we are going to go through all the functions we need in order to achieve what I have just described. And then in the next video, we are going to build this Streamlit app from scratch that does exactly what I have just described. First, we need to select what data we want to pull from Binance API. So over here, I'm bringing the last 2 days worth of data and I'm using the 15-minute interval. Then I am running regression analysis in order to identify Bitcoin's trend. And as you can see, positive. Then we are trying to identify the best performing EMA. And you can see all these EMAs over here and their velocity and efficiency and their combined score. Then we are identifying the best performing coin in relation to Bitcoin. So over here, we are using correlation, sensitivity, and trend direction analysis. And then after we have identified the best EMA and the best coin, which in our case right now is the 15 EMA and Gala USDT, we have a plot over here where we are suggesting our trade. And as you can see over here, we are suggesting to buy over here, sell over here for profit, and then sell over here for loss. We actually have the values at the top. So this is a price to sell, price to take profit, and the stop loss over here. Additionally, in the next video, I'm also going to show you how you can back test this strategy. So over here, we have all the possible trades using the best EMA and the best performing coin. Also over here, I have the budget. So we are saying, had we invested 3,000 and we were taking all the trades in our strategy, then we can see at the top, we are going to have a 51% win rate, profit over here. Best coin is Solana, but we also have all the other coins and their profit and loss in case we are using another coin. Down here below, I'm also having all the details of the trades, the buy, the sell, the profit, and the loss. But again, this is something we are going to explain in the next video. In this video, we are going to go through our strategy and how to build this Streamlit app. And before we start the video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enable notifications for my future videos. Right, starting with the first thing we have to do is that we have to go through all the libraries we need. So make sure you have all these libraries. If you are missing any of these libraries, then you can quickly do pip install and then the name of the library. So Streamlit, for example, enter, and this is going to install the library. Then you're going to need to pass your API key and secret. So this is something you are going to get from your Binance account, and in the API management, you can actually create a new API that is going to give you the key and the secret. You need to copy it, paste it over here and hide this so you can actually run it. And then down here, you need to initialize the Binance client. And then down here is a function that we use to pull the data. This function is actually provided by Binance. So this client.get klines. So I have copied and pasted the function. And this function, if we run it, is going to return, let me run this too, is going to return the timestamp. So this is the columns I have actually selected. timestamp, open, high, low, close, and the volume. And this is what we have now in this data frame over here. We have the Bitcoin's data basically for the past 2 days using the 15-minute interval. Then the next thing we do is that we are running our regression analysis. So we create this function that takes as input this data frame over here, which is the Bitcoin data frame. Then we are separating our data into X and Y. X is going to be the date, and we are using the length basically. So 1, 2, 3, 4, 5. Y is going to be our close price. We initialize our model. We feed our model. We predict on our model. And then we store the first coefficient into the slope. And then if this number is higher than 0, then we have a positive trend line. Else we have a negative trend line. We are also returning the Y predict, so we can actually plot it. So if I run this function over here, I am saying BTC trend, comma, Y predictions, because we are also returning the Y predictions. We are calling our function. We are feeding this data frame we have, and then we are visualizing it. So you can see we have a positive trend. And if we also run this, is going to be the predictions. So this array is basically going to be this dotted line you see over here, our predictions, and you can see is positive. If I go back, the next thing we are doing is that we are creating the code to plot our regression. So this function takes as input the data frame, the Y prediction, and also the height. I'm going to use 500 on this one. So it's a bit smaller. And then over here, we are setting the figure size. We are plotting the timestamp and the close. We are adding labels and colors. Over here, we are plotting our prediction. And this line is actually the dotted line you see over here. We are adding a title, X level, Y level. We plot the legend, which is over here. We plot the grid. And we also saying st.pyplot because later on, we are going to run this in Streamlit. That's why you see the ST. But to visualize it in Jupyter Notebooks, you don't need the ST. You just need to run this code over here, and we are going to have our visualization. Right. Next, we have the two metrics we are going to use in order to identify the best performing EMA. The first one is the velocity, and the second one is the bounce rate efficiency. So the velocity is basically going to be, let's say we are using the red EMA, which is the 20 EMA. Velocity is actually how far up or down the price travels when it touches the EMA. For example, let's focus over here, let's say, when Bitcoin's price came down and it touched the EMA, how far did it travel afterwards? Same case over here, when it came down to touch the EMA, how far did it travel? Same over here, when it touched the EMA, how far did it travel? And the velocity is basically calculating all the touches, then it's calculating how far it traveled, and then it averages that into a velocity. So if we go back over here in the code, it takes as input the data frame, so the Bitcoin's data frame, then the EMA column, which we are going to calculate later on. And in this example, the EMA, we use the 20 EMA to explain the example. And then it takes the number of Ks. Next, it calculates how many touches we had. Then it goes through all the touches. It's calculating the reaction, which is basically the velocity from the touch to the ending point. Then is using the mean, which is the average, and is storing that into velocities. The bounce rate efficiency now is pretty much doing the same thing, with the only difference that it's not using the average velocity. We are actually setting a threshold, which is basically counting the number of important bounces. So it says over here, the function calculate bounce efficiency calculates the efficiency of price bounces after the price of the asset touches the EMA, and is measuring the significant bounces. And these significant bounces we are going to define by setting a threshold. In our case, I've set the threshold quite low, but we can play around with the threshold. So again, we calculate the touches, and then we go through all the touches, we calculate the velocity, and then we check if that velocity is above our threshold. If yes, we are saying it's a significance bounce. If not, then 0. And then we are dividing the significant bounces by the length of all the bounces, and we are returning the bounce rate efficiency as a percentage point. Now, in order to test these two functions now, we need to create another function, which is the next one. So identifying the best EMA. And what this is going to do now is that it's going to loop through a lot of different EMAs. So over here, I am saying for period in range, it's going to start from the EMA 15th and it's going to go all the way to EMA 91. And each time it's going to be adding 2. So it's going to check EMA 15, 17, 19, 21, etc., etc. Then it's going to calculate the EMA period by using this exponential moving average function over here. Period is going to start from 15 and then it's going to add on. And then we are going to calculate the velocity and the efficiency, which is basically these two functions we have above here. Next, over here, we have an error check. If we don't have velocity or efficiency, we're going to have zeros. And next, we are storing our results into our results over here. So we store the period. It's going to start from 15. We store the metric, which is basically EMA underscore and then the period. And then we store the velocity score and the efficiency score. Over here, we are converting everything into a data frame. And then over here, we are scaling our two metrics into a number between 0 and 1. So we can actually combine them together. Down here, I am saying that the metric efficiency for me is more important because it actually has a threshold. So I'm saying give a weight of 0.59 to the efficiency and a weight of 0.41 to the velocity to create the combined score. Then we are going to sort our results using this combined score, and we are going to select the first row, so the best performing EMA, and store it in best over here. And I think we are doing this because we are going to return this best in order to suggest the trade later on. Next, we are going to plot our results. So it's exactly the same for loop as we had above. Next, we are initiating our candlestick chart over here. We are plotting everything, the open, the high, the low, the close, and then the name. Then we are adding the EMA line we are looping through. So it's going to start from 15 and it's going to go all the way to 91. Then we are customizing the layout for this chart. So we are setting the titles, the y-axis, the x-axis, the legends, and then the template. And then we are saying figure.show so we can visualize the plot. And down here, we are returning the best metric and also our results. So if we run this now, and then we run our function, so our function returns the best metric, which we are going to store over here, and also all the metrics, so the data frame with all of our data, and then it takes us input our BTC data frame. You can see over here that we start with BTC 15 EMA, and you can actually see the EMA, and then it goes all the way to 91. So the last one, if we check, let's see, is, oh, sorry, it's actually 89. So it doesn't touch 91. And then if we run all the metrics, so we can visualize, you can see that EMA 17 is the best in terms of combined score, because it has the best scale velocity and the best scale efficiency. The next one, as we can see, is probably the 15. And then let's see, do we have anything higher? No, that's actually the best. And the reason we get a good EMA on the lowest periods is because we have used the 15-minute interval. If we increase the interval to 30 minutes or 1 hour, we are going to get different results. However, let's go and visualize it so we can see this one is the best. You can see it's not bad. Every time it touches the EMA, there is a reaction. Not here, not here, but there is reaction here. There is reaction, let's see, here, 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 good reactions over here. Yeah, it's not bad. It actually looks like it's a good EMA. We can actually visualize the rest in case we want to use a different one. But in order to do it in an automated way, you need to set some calculations in place, which is why we created this efficiency velocity. Right, the next thing we have to do now is to calculate the correlations between Bitcoin and all the other coins. So we can identify other coins, not Bitcoin, in order to trade, because usually they have better results. Right, in order to do this now, we are creating this calculate correlation and sensitivity. This is going to take as inputs the base data frame, and the base data frame is actually going to be down here. You can see is the Bitcoin's data, the base. The target is going to be the target data frame. So we're going to look through all these coins over here and we're going to store them into the target data frame. And then what else do we have? The number of decimals, which is how many decimals we want to return. Next, over here, we are calculating the percentage change, so difference for every 2 rows on the base data frame and on the target data frame. Then we are aligning the indices, so we make sure they both have data in the same row. Then we are running correlation, and then we are running regression in order to get the coefficient. And then from the coefficient, we can actually get the sensitivity. And the sensitivity is the percentage of change. So let's say if Bitcoin goes up by 1%, then XRP is going to go up by 1.7, for example. It's actually the percentage change. Next, we are running another regression in order to get the trend direction. And again, the first coefficient is going to give us the trend direction, whether the coin is going up or down, positive or negative. Next, we are going to scale all 3 of our variables, which is the correlation, the sensitivity, and the direction over here, to a number between 0 and 1. And then I'm assigning a few weights on those 3 scores I have. So I'm saying that the trend direction is actually the most important for me. So I'm giving it a weight of 0.37, so 37%. Then I'm saying the next most important is the sensitivity, and the next most important is the correlation. Next, I am rounding all 3 of them with 4 decimals, actually all 4 of them, because now I have 4 variables. And I'm just returning all of these metrics I've just calculated. So if we run this function and then we test the function down here. So first we need the list of coins. Then we need to say for coins in coin. So for each coin, I'm going to run the fetch data for the coin and store it into the target data frame. I'm going to repeat the same for Bitcoin. So this is not changing. This is always Bitcoin. Next, I'm going to run this function we have just explained, and I'm going to store the results in this data frame over here. Sorry, this is an object, and then I'm making it a data frame when I have the final results. So if I run this and then I run the results, this is going to take some time because it's going to fetch data for all of these ones, run correlation, sensitivity, trend direction, against Bitcoin, and then return the results. There we go. We have our data. So we have the coin, the correlation, the sensitivity, and the trend direction. As we can see, the coin with the highest combined score is, this one is high, 0.85 is higher. Let's see if there is a higher one, 0.85, 0.85 again. 0.84, 8566. Okay, this one seems to be the strongest for now. Let's see. Yeah, so the best performing coin in terms of the relationship it has with Bitcoin and also the sensitivity and the trend is actually this coin over here. So if we have to suggest a trade, maybe we can use this coin over here. Right, moving on, what do we have? We have the suggest trades function. So this function takes as inputs the base data frame, the target data frame, the best metric, and also the trend, if it's positive or negative. So the way we are going to suggest the trades is that we are going to calculate the high and the low for the specific time period. and that's basically the variance. So what was the variance that the price moved on? And we are going to say that we want the take profit to be 1/6 of the total variance of that time frame, and then the stop loss is going to be 1/4 of the take profit, so 25% of the take profit. And down here, all we are saying is that if the trend is positive, we are looking for longs and we calculate the take profit and the stop loss. And then if the trend is negative, we are looking for shorts and we calculate the take profit and the stop loss. Actually, we also have another condition over here. For longs, we want the price to be positive, the trend to be positive, and also the latest price has to be above the best performing EMA. So we don't want to take a trade if the price is below, because even though the trend is positive, maybe for that time it's actually trending a bit negative. That's why we have two conditions for positive and also same case for negative. And now in order to run that function and test it, let me run it. We have to say if the trend is positive, then sort our data frame based on the combined score and take the top 0, which is basically the first row, the first coin, and store it into best coin. And then if the trend is negative, you have to do the same, but in this time we are not ordering ascending, we are ordering descending. So we get the best performing coin when the trend is negative. Next, we are getting the data for this best performing coin that we have just calculated above here. Next, we are calculating the EMA for that coin by using the best metric, which is actually the best performing EMA. In our case is EMA 17. And down here, we are running our function we have just explained. So if we run it again and we scroll all the way down, you can see we don't have any signals because probably the price is below that EMA line. That's why. Let's check. So EMA 17 is 0.81 and the actual close is 0.815. Yeah, so the price is below this EMA. So since we are looking for longs, we don't have any signals because this price had to be higher than the EMA. So when it comes back to touch the EMA, that's when we want to add the signal. However, it's lower now. That's why we don't have any signals. Right. The next thing we are doing down here is that we need to plot our trades. So we create this function over here. It takes inputs of the data frame, the metric list, the title, plot position is true, future time minutes is how far ahead we want our position to be, and the height is how high we want our graph. First, we are calculating the future time just because every time we change the interval, so 15 minutes or 1 hour, the future time is going to be different. That's why we are calculating the future time. Then we are initializing our candlestick plot. We are plotting everything, the timestamp, the open, high, low, and close. Then we plot our metric. So our metric is only going to be one metric. It's going to be the EMA 17 in this case. However, I have a loop here just because in the main app over here in this visual, if I expand it, I am using the top 3 EMAs. That's why I have a for loop there, because I'm plotting more than one EMA. However, if I go back down here, we are only going to plot one EMA, the best performing. Next, I'm saying if plot positions and signal. So if we actually have a signal over here, if he was saying yes, and then we had the take profit and stop loss, then if is long, I want to add a shape, and the shape is going to be a rectangle. The high is going to be, where is the high? So the x-axis is going to be from the current timestamp all the way to the future time, which is calculated. So how far ahead we want to show our position. Then in the y-axis, it was going to be from the metric list, so from the EMA all the way to the take profit. And then we are going to use a green color. And then for the stop loss is exactly the same again. Same span from the actual timestamp all the way to the future. Then it was going to plot from the EMA all the way to the stop loss, and it was going to use a red color. Else, if it was negative trend, then we are going to do a short with the opposite code as we have above here, because it's a short. Over here, we are just adding titles and then the x-axis labels, the y-axis labels, the height. If we are going to allow vertical zoom, and then down here, what do we have? The horizontal range slider, which is this slider you see over here. Right, so if we run our function quickly again, you can see we have the CRV data. However, we don't have a suggested trade, just because if you see over here, the current price is below our EMA. So that's why we don't have a suggested trade. Next, we have some back testing code, which we are not going to cover in this video. I'm actually going to create a whole new video about the back testing, and we are also going to create a whole new dashboard over here for the back testing. So we're just going to keep the back test. So skip this. There we go. So the last thing we have to do now is that we have all the functions needed. And the last thing we have to do is that we have to create our Streamlit app. However, I'm going to leave this in the next video. In this video, we have just explained all the functions. In the next video, we are going to put all the functions together in order to create this app over here that does exactly what we have explained in the functions. Right, so I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, I would really appreciate it if you click the like button, subscribe to my channel, and enable notifications for my future videos.